Hi. Maiksi lang tong topic na to. This is three-phase power. I skipped this before because I want to emphasize kung ano yung difference ng balance system and an unbalanced system. Now, sabi natin before, as we have discussed, your unbalanced system is defined by the unbalanced delivery of power on three phases, meaning you have a three-phase system with phase A, phase B, and phase C, where the power for each phase A, phase B, and phase C are not equal. So that makes your system unbalanced. So what is three-phase power? As I have said before, on as I have always saying, power is always additive regardless of the connection. Whether it's in series, it's in parallel, it's in delta, or in Y, power is always additive. So, ayan, this one. So basically, your power equation is ito lang talaga. Yan. That's the power equation. Okay? Where the total power of a system is just the summation of all of the powers in each phase, SA, SB, and SC. Where the power at each phase can be defined as voltage times current conjugate, V times I conjugate. Derivatives of this equation can be your I squared magnitude of I phase squared times Z. Sorry for this conjugate. There should be no conjugate here. And of course, you have V magnitude of V squared in each phase divided by their corresponding Z conjugate. So those are the derivatives of this equation. Now, for a balanced system, we know that the power at each phase is equal kasi nga the system is balanced. Therefore, we can say that SA is equal to SB, which is also equal to SC. And that makes your power equation SA plus SB plus SC equal to 3 times S phase, because S is equal to in each phase. So that's basically your three-phase power. That's it. Now you can use this power for power factor correction. Your power factor is still power total divided by magnitude of S total. It's still it's still cosine of theta on your power triangle. It can be leading or lagging, whether depending on whether the circuit is capacitive or inductive. So yeah, that's it. That's three-phase power. I think I want to emphasize more on this equation. This equation is actually interesting. This S total all of is equal to 3S phase. This will work if your system is balanced. Now the thing here is that if you have a balanced system, your total power is just equal to 3S phase, which is also equal to 3 times V phase I phase conjugate. Now what's interesting here is that most of the time your voltage and current parameters are given as line-to-line parameters or line parameters. Therefore, you won't really see parameters that are given in their phase values. So for current, most of the time, what's given or what's required is the line current, and for voltage, what's usually given or required is your line-to-line voltage. Therefore, we may want to represent this equation into line parameters. So for Y systems, your I phase, this one, is just equal to I line. So it's just 3 times V phase I line. However, your V phase is not equal to V line to line. It's actually V line to line over square root of 3. Now, if we talk about the magnitude, I think we should emphasize this. If we talk about the magnitude only, so we're only interested with the magnitude of V phase and I phase. For that actually simplifies things, because for your V phase to be V line to line, you just substitute V line to line over square root of 3 here. So you now have 3 times V line to line over square root of 3 times I line. I line. You don't need that conjugate anymore because we are talking about the magnitudes only. Now, if you multiply this by square root of 3 over square root of 3 to remove the radical here in the denominator, you can actually cancel this 3 and square root of 3 times square root of 3 here. So that leaves you with an equation that is this one. Sorry. Square root of 3 V line to line I line. But take note, these are just magnitudes. Now, what if your load is in delta? So if the load is in delta, I'll rewrite the equation here. V phase. Again, we're talking about the magnitude. I phase conjugate. I don't need that conjugate anymore because we're talking about the magnitude. For delta, your V phase is equal to V line to line. However, your I phase is equal to I line over square root of 3. Again, we're talking about the magnitude. As you can see, you have the same equation as that in Y. So it doesn't really matter whether it's in delta or in Y. So yeah, I think that's three-phase power in what do you call this, per phase power equation in line-to-line parameters power factor. I'll talk about power factor correction later. So yeah, see you.